Everybody, it's Tyler here at Riverbots High School, and I'm checking with 3004A qwerty. Wow, they have a Tier 3 climb. We just saw it happen on the practice field. It is absolutely incredible, and we can't wait to talk more about what's going into that. A lot of great things that go into this robot. We talk about the inspiration behind that as well, too, and some cool solutions. They made this cool wing solution, make sure they can climb up and not swing correctly. Talking about a PTO with it as well, a couple macros and some other great stuff. We'll be learning more about qwerty coming up here on Bits and Parts. Alex, let's talk about this Tier 3 climb and some of the inspiration behind it. Where did you draw from in order to create something like this? And we'll be going more into kind of the whole structure for it.
Yeah, so when we came into the season and we saw there was climb, we really looked into FRC because they've had a lot of elevation in the past, like FRC 2022. So we found a team called FRC 95, the Grasshoppers, and we looked at their climb with the active hooks here and the passive hooks, and we thought that is a really good way to, climb in VRC because it's really doable. And then we saw it actualized in a Vex robot by some Taiwan team, and we realized, wow, we should really get ahead of this. So around a month ago, we started developing this climb.
So how does that translation work between going from, taking inspiration from an FRC robot to utilizing Vex structure and creating it? Like, what challenges were there to try to replicate and create something like that on this?
So a lot of Vex parts aren't strong, as you can tell. This was really bent yesterday, and that was pretty much the biggest challenge we faced because all of the other structures are really, straightforward on the climb because it's just two arms that come up and down. We thought of using poly hooks because they had machine metal hooks, but then we realized we didn't have time for that, and the standoff hooks worked perfectly fine.
So talk to me more a little bit some of the structure. Let's deploy the climber up and see how that works, and just kind of walk me through how that whole process of doing a climb actually works.
So when we deploy the climb, we have the string resting here, and then once we deploy the climb, our rubber bands pull this back and our pistons pull this back so that the climb is ready to hook forward onto the bar.
And so you guys are going up on the bars, you're going through multiple stages, right? So how does that work for each stage then?
So what we do is our winch pulls down this arm, so it's underneath the passive hooks, and then it lets up so that the passive hooks grab onto the bar, and then this goes back. I can't push the pistons. It goes back, and then we put onto the next bar, and then it drags down again, right?
And I saw on practice field, it was about like 15 seconds or so, right? Is that what you try to target for the climb?
We want it to be less than 15 seconds because sometimes it's not as viable in matches. And in skills, we want to have as much time to score other rings as possible as well. So we're aiming for sub 13 or even sub 10 seconds, but 15 seconds is what we have.
Which I still think is plenty impressive as well, too, with it. Tyler, let's talk about, I noticed when we were talking earlier, you mentioned this wing solution that you came up with here. So talk to me more about coming up with that, and then as well too utilizing a PTO for this also.
Okay, so one of the main issues we encountered while building our hang is that the robot's natural center of gravity causes it to shift forward while we're climbing the ladder. So this wing will keep us upright and parallel to the ground while we're climbing. So essentially what this does is it sort of almost clamps onto the pole of the ladder, and this is going to prevent it from shifting forward or any sort of swinging movement, and that allows us to stay parallel throughout the climbing process.
Very cool. And from testing that, this just was overall the best design. Did you come up with any other potential designs for this type of wing at all, or any other shapes maybe?
We mostly just focused on sort of like a triangle shape since triangles are the strongest.
Sure.
And we just, one of the issues we may have encountered was where to mount the piston. So then ultimately we decided to put it on the drivetrain here, and we use zip ties to maneuver it easier.
And how about the PTO you have in robot? Tell me more about that.
Yeah, so since we don't have enough motors, of course, to do a full climb, we had to resort to a PTO. So this allows us to shift a gear to connect with the drivetrain, and then using the drivetrain, we can turn this, which will in turn turn the spool to wind and unwind the string, and that's going to allow us to climb.
And were there any other issues that you guys had to work through and deal with in terms of the climber at all?
So one more issue was that even with the wing, even with the wing, the robot would still tilt forward on the other side because you see how the wing hooks onto the vertical bar, but this side isn't supported, right? So this would still kind of go into the robot, and then it would get stuck on the intake here. So we added these kind of shields that we've seen on Gremlin. They have polycarb shields, but we decided to add C-channel shields because we needed to be very strong. And then that just, helped our robot, even though it still tilts a bit, it helps our robot actually get onto the next bar.
And wrap you up on this, Ethan, on here. Talking a little bit more of the macro that you developed for the hang itself. And then also, we were talking earlier, you have an Auton selector you want to talk a little bit more about.
Oh yeah, so our macro is pretty simple for the hang. So the driver starts by pressing 3 buttons at once to stage a hang that we showed earlier. The reason why it's so complicated is because we don't want the driver to accidentally be staging the hang mid-match, right? So after it's staged, it'll end up like this. And the driver will press another button to bring it forward. And then once it's forward, they can press the same button they used to stage the hang to actually initiate the hang. And the hanging sequence is completely time-based because we found that it was good enough to get a fairly consistent hang, and it was also much simpler to program. We just separate each hanging sequence into multiple segments. So we have the initial winch in as one sequence. We also have a winch out sequence, and then we have the sequence to evade the bar. And then by splitting them up into these 3 segments, we're able to time each one accordingly, and then allow us to have a very effective and simple hang macro. As for the autonomous selector, as you can see here, we have a very simple autonomous selector. It's still a work in progress as we plan to add more features, but the main part is working. So you can press this button, and we have access to all these different autonomous that we have coded up. So, but we can just press on a button and immediately switch to the autonomous that we want to run for the round. This is good because we don't have to take our computer and upload the right autonomous every time we want to go up before the match. Another thing that's pretty cool about our Auton selector is that it reads and writes to the SD card. And by writing to the SD card, we're able to sort of save config configurations for future rounds. So that say we want to select, say we're tuning our red Auton on the practice fields. We don't have to keep fiddling around with our brain at the start of every round, because all the configurations that we want is saved to the SD card, and it makes it pretty simple.
Well, Qwerty, first off, congratulations. Getting a Tier 3 climb going is incredibly impressive in this game so far. I know you'll continue working on iterations for that, so we can't wait to see what you come up with, as well as a tournament win already and Judges Award back at Haunted too. So congrats on a great season so far. Can't wait to see how you do, and thanks for sharing this incredible design. I know teams are going to take a lot of inspiration from this, and wish you best of luck here at Riverbots as well too. Thanks a lot, guys.